Okay, let's continue with Module 2 on descriptive statistics, and this will be part 2. Now let's turn our attention to quantitative data. Now we have actual numeric data rather than the categorical variable we looked at before. Some of the tables and graphs are going to seem quite similar to what we used with categorical variables, but a little bit different. In terms of tables, we can still set up the data in a frequency distribution or relative frequency or percent frequency as before. We can also do something with quantitative data that we could not do with categorical data, and that is what are called cumulative distributions. In terms of graphs, we can draw a histogram, which will look very much like a bar chart with a little bit of difference to it. And we can do stem and leaf displays. There are actually several more different types of tables and graphs that you can do, but we're not going to try to cover all of them here. Let's use a numeric example as we go through this section of the topic. Suppose we got the manager of Music Mania, a record store, and they're interested in the age distribution of their customers. Suppose they take a sample of 40 customers, and we got the following ages. Again, as it is, this is just 40 numbers in front of us. It doesn't tell us much to look just at the 40 numbers. But perhaps we can use tables or graphs to put it in some type of manageable form. Again, we can start with a frequency distribution. However, since we have so many different numbers, we don't want to use the numbers themselves as individual categories. It's typical with quantitative data to break the data into classes, such as we could count all of the ages between, say, 10 and 19, 20 and 29, and so on, in order to set up our frequency distribution. Now, there are no absolute rules for setting up these classes, but there are some general guidelines. We usually don't want too few classes, and we usually don't want too many. Usual suggestion is somewhere between 5 and 20 classes. You should avoid overlap in your classes. I'll show you that a little bit more in a moment when we get to a distribution. You want to keep the classes of equal width for comparison purposes. And if you think about it for a moment, we have to have enough classes, and they have to be wide enough to cover the entire range of the data. One way to do this is choose the number of classes you want, and then we can say the width of the class has to be the range of the data divided by the number of classes that you've chosen. And since this will usually turn out to be a fractional value, we can round it up to a convenient number. The range of the data, which most of you already know what a range is, and we'll be talking more about this in a future module, the range is simply the difference between the largest value and the smallest value. So for example, suppose we decide we want to break our data into 6 classes. If you go back and take a look at the data, the largest number in the data set was 67, the oldest age was 67, and the youngest was 11. 67 minus 11 is 56. Divide that by 6 classes. Turns out to be 9.33, and we're going to round that up to a convenient number like 10. And that basically says we should make our classes 10 units wide in order to cover the entire range of the data if we want 6 classes. So I'm going to use the classes 10 to 19, 20 to 29, 30 to 39, etc. The difference between the bottom number in each class gives you basically the width of the class. So 10 to 20 to 30, etc. is a width of 10 units. Again, if you go back to the data that I gave you a moment ago, let's go back there. And if you simply count now the frequency in each of our classes, you should come up with the following distribution. 8 of the ages were between 10 and 19, 10 were between 20 and 29, and so on, out of our 40 sampled individuals. Again, we can change this to relative frequency and percent frequency. Relative frequency, again, as before, simply takes the frequency and divides it by n. So for example, 8 divided by 40 is 0.2. 10 divided by 40 is 0.25. And if you continue in that way, you will get the relative frequencies listed here. Once again, as always, relative frequencies have to sum to 1. Move the decimal over 2 places to the right, and we convert this to percent frequencies. And again, the percent frequencies have to add up to 100%. Once again, those were examples of tables. Now we can go to graphs. First graph we'll look at is a histogram, which, as I said before, looks very much like a bar chart. But unlike a bar chart where we separate the bars for a categorical variable, we're going to squeeze all the bars together because we've got numeric data on the horizontal axis now. Once again, we can take our data and put it into a frequency histogram, or a relative frequency histogram, or a percent frequency histogram. So on the horizontal axis, we will plot the values for the variable that we're looking at, in this case ages. And on the vertical axis, we will put either a frequency, relative frequency, or percent frequency. Once again, keep the bars or rectangles of equal width, only vary the height. Here is an example of a frequency histogram for the data that we've been looking at. We had a frequency of 8 people in the 10 to 19 age group. We had 10 people in the 20 to 29 age group, and so on. If I had wanted to eliminate this gap down here at the bottom, I could have used a little symbol to indicate a break in the axis, and I could have moved these rectangles over to the left. But in this particular case, I chose not to do that. Once again, the purpose of a histogram is to give you a visual look at your data. You can quickly see which age categories have the greatest frequency, where the greatest number of your customers come from in this case, and how the ages are distributed. There's another table that we can do now with quantitative data that we couldn't do with categorical data. We can do what are called cumulative distributions. A cumulative will add up or accumulate all the data less than or equal to the upper limit of your classes. Once again, we can accumulate the frequencies, or the relative frequencies, or the percent frequencies. Let's take a look at a cumulative, and then we'll flash back and show you exactly where these numbers come from. I'm going to take my categories now and change them a little bit. I'm going to take the upper limit of the categories. The upper limit of our classes was 19, 29, 39, and so on. And we're going to look at all data less than or equal to those upper limits. Everything less than or equal to 19, less than or equal to 29, and so on. And then we can accumulate the frequencies, the relative frequencies, and the percent frequencies. Let's go back to our original data just to make sure that you see where this is coming from. We know that there were 8 people or 8 customers between the ages of 10 and 19. So by the time we got to the number 19, we had accumulated 8 of our observations. By the time we get to 29, we have these 8 plus these 10 for a total of 18. By the time we get to 39, we have 8 plus 10 plus 8 for a total of 26. And if you continue in that way, you will get these cumulative frequencies right here. 8, 18, 26, 32, 36. And by the time you get to the last category, of course, all 40 observations had to be less than or equal to 69. In exactly the same way, you can accumulate the relative frequencies and the percent frequencies. Let's go back for a moment to relative frequencies. By the time we get to an age of 19, 0.2 of the data has accumulated. By the time we get to 29, 0.2 plus 0.25 for a total of 0.45 has accumulated. By the time we get to 39, 0.2 plus 0.25 plus 0.2 for a total of 0.65 has accumulated, and so on. And that's where you will get those cumulative relative frequencies. Notice that cumulatives basically always go up. They always increase until you get to the end of the distribution. At various places in a statistics course, we sometimes use tables out of the book that are cumulative in nature, and we'll explain some of that later in the course. Also, there's many situations where you want something similar to a cumulative. If you want to know what fraction of a distribution is less than some point, a cumulative value will help you. Okay, let's talk about stem and leaf displays as another type of graph that we can use to display quantitative data. A stem and leaf display is kind of a nice alternative to a histogram in a way. If you just have a histogram, if you just have the graph itself, while it can show you the frequency in each class, you no longer know what the individual numbers themselves were. A stem and leaf display is actually going to show us all the data. It's going to show us all the numbers. And as you'll see in a minute, it almost looks like a sideways histogram. The first digit or digits of the numbers in your data set make up what's called the stem, and the remaining digits are called the leaf. You put the digits in the stem to the left side of a vertical line and the remaining digit to the right side. Here's what a stem and leaf display for our data would look like. All of our numbers began with either a 1, 2, 3, 4, 5, or 6. We had ages that ranged from 11 on up into the 60s. So those first numbers are what we call the stem. The remainder of the number is called the leaf. And so we actually have the entire data here. This means that we had somebody who was 15 years old in our sample. We had somebody else who was 14 years old. Somebody else who was 11 years old, somebody who was 19 years old, and so on. Again, if you don't see that, let's go back to our original numbers. We start with an age of 15. You'll plot that as 1, and then you'll put the number 5, so for the value of 15. Similarly, 30 and 25. You'll have somebody who's 30, 30, and somebody who's 25. As you get more and more numbers with the same stem, you want to carefully line them up on top of each other, so that by the time you're done, it's almost like you have a sideways histogram. Think about turning your head sideways and looking at this diagram, and it's almost going to look like a histogram. The longest row quickly shows us where the greatest frequency of data lies. Sometimes it is common to rank order stem and leaf diagrams. So let's do that here. It's the same numbers we just had, but we've put them from lowest to highest. The youngest age in our sample was 11, then 14, then 15, 16, and so on up to a high of 67. There are a couple of advantages for a stem and leaf display over a histogram. First, it's somewhat easier to construct by hand. we didn't have to sit around and decide how many classes do we want. Do we want 5, 6, 7? What should those classes be? Also, you get to see the actual data themselves, the data points themselves. As I said before, a histogram, if all you have is a histogram, you know that there was a frequency of 4 or 5 or 10 in a certain class, but you no longer know what the data themselves, what the points themselves were. With a stem and leaf display, you actually have the original numbers. When I do grade distributions in my various classes, I often draw a stem and leaf display. It's a nice, easy, quick thing to construct. You can go from the lowest grades to the highest grades and quickly see what the distribution looks like. Okay, that's the end of the second part. Now in the next part, we're going to take up two variables. So far we've been talking just about one variable and tables and graphs that we can utilize. There's a variety of techniques that can be used to look at two variables.